Hello YouTube viewers, welcome to my channel Science and Technology. In today's show, Future Friday, we're going to talk about Donut Labs solid state magical battery. So let's dive deep into it. Now, what is this? Well, you have to understand, this is the holy grail of battery technology, solid state battery. Why? Well, it's almost like magical. For example, it will give you everything, meaning you want more kilowatt hour. It's like, I got you, fam. You want more kilowatts. I got you. You want rapid charging and discharging. It's like, I got you. So it will give you everything that you could not even dreamt of. So 400 watt hour per kilogram. Now, if you are not familiar with that number, think it this way. The best lithium ion chemistry, give or take, is a nickel, manganese, cobalt, topology. That topology maxes out. And again, those are very flammable technology. And this puppy is like, yeah, I am 2 to 3x more than that. And be mindful, nickel, manganese, cobalt goes boom like this. So they're like, okay, we're going to give you 2 to 3x power. Okay, so far digestible. Hyper fast charging. This puppy can touch 12C. To give you a context, C is basically 1C is 1 hour, 2C is 30 minutes, it goes down. So normal lithium ion, no matter which chemistry, generally is 1 hour. Like, wait a minute, then why don't we have rapid charging and fast charging in our phones? Pay attention to it. Almost all of them will always say 0 to 80%. It will never be 0 to 100%. Lithium ion inherently has that limitation. Only lithium titanate oxide has the ability to go from 0 to 100 under 1 hour. Not just 0 to 80%. So basically 0 to 80% is like constant current kind of scenario. So you can pump a lot of current. As long as you can cool the cells, you can dump a lot of current. But once it reaches a certain point, it has to switch to constant voltage. Otherwise, so yeah. So 1C, which mind you, compared to lead acid batteries, that's lightningly fast. But this goes to 12. Like 3C is acceptable. Like that's how much you can achieve, like 15-minute charge and discharge. On lithium titanate cell, that's like the best you can expect. This puppy is 12, 5 minutes charging and discharging. Damn. That's like, damn. On top of that, 100,000 cycle life. Meaning you're not even talking about a electrochemical cell, you're talking about a capacitor. Capacitors are rated in this sort of number. So, yeah. Okay, so far digestible. The temperature range, it works at minus 30 degrees C. Okay. 200 degrees C. Whoa. I'll explain why that 100 degrees C part is the press X for doubt, but it beats lithium titanate oxide. Like lithium titanate, minus 30, I got you, fam. 100 Celsius? Boiling water? Yeah. So that is it. And it's safe chemistry also, meaning there is no boom potential. So if you are like, wait a minute, this sounds way too good to be true, let's dive deep into it. So what is Donut? Well, Donut is a Finnish company that was founded in 2000. And this is the oldest registration I have seen, and logo was the same, so I'm pretty sure it's the same company. And the first product they ever launched was Donut motor. This puppy, basically a hollow shaft motor, basically in-wheel electric motor. Now they claimed it is the best ever made, as like, you know, there is nothing else. Now that was the biggest red flag because they say they are working with hundreds of OEM, original equipment manufacturer. Basically, like Bosch is a OEM. They make motors and they sell it to other people. ABB is one of those things. So be mindful, motors are a solved technology. So if any Tom, Dick and Harry is saying they are doing quantum leaps, that's not possible. Like thermodynamically, that's not possible. It's like if you have basically motor, like basic motors are like 95% EV motors. Like 92 to 93 is like low cost motors. 95, you're spending money. The world record, that motor made by ABB established in India, that's a brushless synchronous AC motor. That puppy is, if I'm not mistaken, 99.13% or something. Like it's so high, it's world record, and it's a megawatt class unit. It's like big puppy. And so if somebody says like, I'm gonna twice as efficient, it's like, where? So that was the biggest, it's like the best motor ever. It's like, and again, another aspect, can you make a motor this lightweight? People don't make it that lightweight for one simple reason. Metal fatigues, even stainless steel fatigues. No matter what you are doing, it will fatigue. And action, if you are applying like GG amount of torque, there is GG amount of counter torque. It will destroy the shell of the motor. That's why we overbuilt it. Like we learned this the hard way. For if you want a motor that lasts a century, which we do have working induction motors that are that old, those only lasted that long simply because they were built like a tank. So, and again, electromagnetism is solved issue. So unless you are making this sort of motor shell out of vibranium, So that was, and again, if you found any OEM that is actually using it, please do share. I failed, genuinely I failed. I'm not talking about any company, oh, we are making a skate, which is like, where's your product? If it is really that good, trust me, everybody will like, sure, job, take money. Oh, it's cheaper also. So it's like, okay. If you find it, like actual customer unit, not review unit, customer unit. So that is that. And they acquired Nordic Nano, this company that was working on nanotechnology in 2025. And using that technology, they made greatest battery ever created in 2026. So this is what we are talking about, this company. And if you're like, this is why people are not very like, trusting to it. Yeah, there is a reason for that. So is there any possibility under the known laws of physics that this sort of battery can be made? Well, the best, like the most charitable interpretation is hybrid lithium ion battery capacitor technology. Something similar to this, let me guess, something similar to basically where you have best of both worlds. Basically, you take the best of capacitor and best of battery. So the closest thing that I know of personally is SIPL's hybrid lithium ion battery capacitor. Now these things can match almost everything of that cell. So basically, what about charging and discharging? That's what everybody is worried about. Like, how quickly can I charge it and discharge it? Here's the deal. Because it's a hybrid capacitor, you are limited by the copper in your PCB, MOSFET switching abilities. Basically, everything that is outside of the cell is the limiting unit, not the cell itself. The cell chemistry is like, I do not care. You will, like 12C, bro, you can go to 100C. Like, they actually did spot welding just to prove the point. So these things is like, bro, I got this. You are the weak problem. Of course, you are not gonna put like 15 kilograms of copper bus bars just so you can hypercharge it in 13 seconds. So this you do not have to worry about. Charging and discharging, you do not have to worry about it. Oh, and this also does not have that issue where if you are draining a lot of oomph out of a lithium ion battery, the range goes down drastically because its efficiency goes down. So here there is no such thing, meaning if you had 10 kilowatt capacity, 10 kilowatt hour, it will remain 10 kilowatt hour no matter how quickly you are draining it. It's not like if you start draining it fast, which will happen in all lithium ion chemistry, it will start to lose capacity. Now, it will not be too drastic, but all the capacity that you hear, like let's just say 18650 cell that is 3000 amp hour, it's at 1C. At 2C, it will be 2700. At 3C, it will be like, bro, 1500. It drops out drastically. This, I do not care. So that is there. Current carrying capacity of your substructures are the limitation. This is like, I got you, electrochemically. Then what about temperature range? Exact same temperature range as that -30 claim, which mind you, there are a lot of chemistry that does lithium titanate, this sort of thing. But all of them, including Nordic Nanotechnology's own website, goes to 60 degrees C. I have no idea how the heck they jumped from 60 to 100 degrees C. Did they just magically invented carbon nanotube? So that temperature range part is like, this is the closest. What about fire safety and all that? So this is the short circuit, and be mindful, this product is actually used by Indian Army in basically cold places known as basically Jammu and Kashmir. So these things are tested in cold temperature, and again Army system, so they had to double check it for safety and all that. It is safe. Why? Because the exhaust is actually CO2. It will create oxygen, but it also has carbon, so it literally creates carbon dioxide. Does not burn, like it creates carbon dioxide, the reaction is there. So instead of having flame coming out of it, you have fire retardant coming out of it. So again, all the testing has been done, so it is a done deal. So okay, then why don't we use it if it's this miracle? Like cycle life, yeah, we don't count it. Like it has the same cycle life technically on paper of 100,000. You do not have to worry about it. Your wheel bearings will wear off before this will give up the ghost. So why don't we use it? Yeah, this has lower density. So this donut company took this, and only one weakness that this technology has, they just reversed it. It's like, okay, instead of 4x lower in terms of basically what you call capacity as in kilowatt hour, they just reversed it. This puppy only goes up to 65 watt hour per kg. That's the only weak link. And again, that's not even technically a weak link, because if you are logical, all you will do is an electric vehicle that has a small battery and you will have a small range extender. Because while everybody opens their mouth is like, I drive 10,000 kilometers, you don't. You live in a world which has traffic, and you're not stupid enough where it's like, okay, I wake up and I drive my kid to 7 hours away from my home. So most of the time, a series hybrid can take care of all this situation. It's an electric vehicle, charging, discharging. This puppy is like, bro, do you have charger to charge me? Other than that, don't worry about it. Lifespan, don't worry about it. And when you're really driving long range, have a small generator. It's like, bro, chill. Again, if I make a car, this is, or industrial vehicle, this will be the technology I'll use. 65 watt hour, fine enough. So what this Nordic Nanowood can have done, almost something similar, but they all their research paper is specifically focused on sodium and carbon nano stuff. So what in carbon nano stuff they could have done? Graphite, graphene, or carbon nanotube, or some sort of structure. That's the only wiggle room they have. Like, they took this, and instead of lithium, they figured out how to have sodium and carbon nanotube to solve its weaknesses, because be mindful, sodium will be even worse than lithium. So unless the geometry gives them some magical abilities, which again, not impossible. Again, graphite and diamond is only geometry difference between the atomic arrangements. Maybe. So that's the only possibility that I've seen. They took this and it's like, hey, this is cool and awesome, but what if we add quantum physics geometry of nanotechnology and cheaper material of sodium? And again, sodium does have the benefit that it allows charges to go in and out much more quickly. So that's the best stretch reality I can give. Be mindful, everything that they are claiming, I can give you that. You just pick up the phone and order this. It's not a big deal. It's just that what hour you have to sacrifice. Other than that, everything else is already here. So this gives us like a very good quality BS vibe, so to say, because again, they had an expo, people went there and everything was 3D printed. I'm like, bro, I did expo last year, basically Delhi Expo, and we had, because I'm working on CV engine, not me as in like I'm the salesman of it. So that engine, we actually made the metal parts and all that, and that was there. Like, you can actually see the metal mechanism, metal hardware. The AO1 engine, that engine allowed us to get the patent. We actually had that also, and people were like, oh, that's how it works. They had a 3D printed one. And be mindful, there were other companies also that they had their own battery chemistry, and they're like, this is our battery chemistry, this is our electrolyte stack, 3D printed. That was like, and on top of that, they were hiding the element. This was like, yo, this is stupid. Like, you cannot hide what element goes inside it, because you are screaming built on abundant geopolitically safe materials. It's like, how do you know it's safe if you do not know what material it is? So that's the whole thing. Like, and be mindful, if they ever actually sell it, that would be the first thing people will know. Like, that cannot be hidden. They'll take the cell, tada. So basic chemistry lab, I'm not even talking like, MIT level or IIT level. A basic chemistry lab will be like, bro, what is in it and at what ratio? So there is no point of hiding that. And be mindful, there are a lot of people who are not familiar with patent and proprietary. You have to understand, patent means you have to actually tell them, this is what we are doing. How you're doing, that's up to you. What we are doing, and they have to understand that. Patent office have to understand it, and then that's how you get a patent. Proprietary, let's say you are making a missile guidance system, you will never patent that, because A, that's top secret. And how the heck it's top secret? Because you are not selling it to common public. And even the military people, even in them, like soldiers, airmen who's like, I'm going to fire this puppy, they do not know how it works. Only very select group of people are allowed to actually tamper with the actual electronics. And it has to be tightly controlled, because if that data leaks out, enemy is like, bro, I got you, fam. So let that be very clear. You have to explain everything. Now, proprietary, there are a lot of things, like let's say how Nutrela, what is Nutrela made out of, but how it's cooked, that's up to you. You can go YOLO on it. Like, same goes with the batteries. Like, you can like, okay, I'm going to take out a Panasonic battery or a Tesla battery, and like, I'm going to cut it, analyze everything. You can do that, and people do that. There are companies who offer you this service. It's just that they cannot tell you how their factory works. That's proprietary. That's why they ask you to sign NDA when you do job there. That is the special sauce, not what is in the battery. How you make the battery, that is proprietary. What is in the battery, that has to be patented. If not, somebody else can patent it, worst case scenario, especially if you are hiding everything. Because again, patent office can't fight a case if you have never shared what the hell you were doing. So that's the part is like, did not, it does not make logical sense. And then I lost it. One of the employees said it's a drop-in replacement of lithium ion, because this is almost like a capacitor and they can control the voltage. Because again, most people were saying, hey, if it's a 4.2 volt, most likely it's a capacitor, lithium system. They're like, no, it has no lithium, right? Lower material cost than lithium ion. It does not have lithium. So how can be 4.2 volts? If you worked with capacitor, we can design capacitor at different voltage. And there lies the main problem. They said it's a drop-in replacement. I'm like, either they are smoking too much marketing, or they are breaking the laws of physics, because every BMS will scream its lungs off if this was attached to it. Because again, it will never go from like, constant current to constant voltage, because it's like, yeah, keep giving me constant current and the voltage will keep rising. BMS will be like, yo, shut it down, this has shorted something. So that's like, no. And again, that's also another thing that's pissing me off, is like, if you could have designed it, wouldn't you increase the voltage of cell? That's the biggest limit. Like, you have so much wastage. We have amp power. We have more than enough amp power. It's just that we have to put so many cells to have voltage high enough. For example, one of my colleague, friend, he's making two-wheeler. He does not want like 80, 90 volt system. He wants to directly go to the same voltage as electric car, like 400 volt. Can he do that? Yes. But there are too many cells. Imagine this cell was rated at 10 volt, 20 volt, or even just double of what lithium ion is. That even sounded cool. It's like, hey, it's 2XL lithium system, 8 volt. So that was like, every BMS will poop out. Heck, BMS has to be calibrated in most of the time. If you use LG cells, it would be a bit different than Panasonic cell, even if they have the same chemistry. So the moment they said that, I'm like, too much marketing or pure BS? So, and again, like, they have the automotive wheel, 630 kilowatt per wheel. I'm like, bro, even truck will be like, bro, it's too much. I'm like, I'm not joking, the truck axle will be like, yo, rubber will be like, a motorcycle 150 kilowatt, that is a bit digestible. Like 21 kilo, 21 kg is like, bro, what metal that made out? Like, because again, even if you're like, okay, what if it's made out of carbon fiber? First, they say flat out it's cheaper than conventional motors. So it cannot be carbon. And even if it will fatigue the hell out of it, because if you're applying that sort of torque, like 300 Newton meter of, like, the drill fights back to you. It's like, so all of it sounds way too, what you call, hubby-dubby. And again, we have been there. This is the old thing. We've been there. It's basically too good to be true. So probably it is. It's like, we've been down this road. And all the claims were too true without having any downside, which again, if you live long enough, you study enough things, you will realize there always has to be a catch. It's almost like a universal law. It's like, you will have some issue to deal with. So, not having that, and an obvious thing, which mineral you are using. If you are using carbon, if you are using sodium, those are the only potential option which can be like, okay, low cost and all that. But like, why you're removing that? Like, why can't you tell that? Like, that's the first thing people talk about. So that is there. And the most horrifying part of it is that people want to believe it. Like, how this woman caused so much damage because people wanted to believe. Like, again, I'm not a big dude, so whenever, like, blood has to be drawn, it's like, bro, seriously, 1 syringe, bro, 3 syringe, what the hell? So that's the issue. She was like, okay, what if it was on drop? We wanted it to believe it, so she sold it. Like, if you want to believe it, like I keep saying that, if you are dumb enough to buy hydrogen, I'm smart enough to sell it. This guy, like, any Tom, Dick and Harry could have any time opened a science book and it's like, hey, hydrogen only has 8 megajoule per liter compared to 32 of a diesel. So even if you have thermodynamic law breaking efficiency of 100%, you still won't be able to compete against a diesel system. That people wanted to believe it. They spent billions of dollars into it, which every scientist who opened a book would be like, bruh, that will not work. Happened. So if you want to believe this, like people want to believe this sort of magical BS battery technology, people will put money into it. They want to believe. That's the most dangerous part of it. Now, is it possible they may have cracked, let's say, carbon nanotube or graphite or graphene, something like that? Maybe. I'm hoping. For sake of humanity, I'm hoping that I'm wrong. It's just that likelihood is very low, especially when I noticed that their Nordic Nano data sheet was like, minus 30 to 60, which again, almost all capacitors can do that. A decently built one is like directly going from that to higher temperatures. It's like, I know there are some capacitors that have those sort of high temperature rating. It's just like, just feels off, just too many good things. Too many, not like 1 or 2, just too many good things. Or maybe they are actually cracked some sort of carbon geometry that we haven't figured out yet. Or maybe carbon plus sodium geometry. Ooh. So, but again, extraordinary claims requires extraordinary proof. We haven't got that yet. So I am very skeptical. So this was my presentation on basically Donut Magical Solid State Battery. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, Thanks for watching.